All right, so these first ones are all on your logic, and this is a nice little recap of all the information there. I'm going to use two different colors to color code these. So we're going to use this statement and write out the inverse, converse, contrapositive. So I'm going to make the first part, the if two angles are vertical, that's going to be pink. And then they are not adjacent, I'm going to make be blue. I know it doesn't show up real great on there. We'll just do our best. So inverse. So up here, if you look at inverse, you're just going to negate both of the things. So you're not switching the order or anything. You're just sort of oppositing them. So not P. So this says if two angles are vertical. So we're going to say if two angles are not vertical. So we just put a not in there. So it said if two angles are vertical, we're just going to write if two angles are not vertical. Then, and we're going to do not for this statement as well. The thing is, it already says not. So you wouldn't write not, you're just going to take out the not. So we're going to say then they are adjacent. So it's like a double negative. So if it already says not and you're negating it, you just take out the not. All right, so this one says converse. Converse means you're just going to reorder it. So it's just going to go the other way around. So it's going to be if two angles are not adjacent, we're just going to take the second part and put it first. So if two angles are not adjacent, then, and then we put the first part, then they are vertical. So converse means you just flipped it around. So you're not changing anything, you're just switching the order. Contrapositive means you do both. So we're going to flip it around and negate both of them. All right, so I'm going to start with the second part and do the opposite of it. So if two angles are adjacent, again, we're just taking the not out of that. So if two angles are adjacent, then, and again, we're going to not the first part as well. So negate the first part. Then they are not vertical. And then the biconditional doesn't change anything. You don't switch the order and you don't negate anything. It's just instead of an if then, you say if and only if. So it's going to be the first thing. So two angles are vertical. Oops. You wipe that out. So two angles are vertical if and only if they are not adjacent. So you don't switch the order, or you don't make it opposite or anything. You just put an if and only if in between them. So two angles are vertical if and only if they are not adjacent. All right, so that's our sentences, inverse, converse, contrapositive. So now we're going to do validity. So these are your laws: law of syllogism, law of detachment, law of contrapositive. So, I'm sorry. I was getting ahead of myself to this part down here. We have to do these first with the symbols in there. So first one, let P represent John wakes up. Let Q represent John does not miss the bus. Let T represent John is late for school. So let's see. If John wakes up late, so that would be P, then he will miss the bus. So we're going to have P arrow, and then he will miss the bus. Now this says John does not miss the bus, and we want it to be he will miss the bus. So we just put like the squiggly in front of the Q to negate that. So it'll be the opposite of that. So this one, if John misses the bus, so again, this says John does not miss the bus. We have to negate that. So squiggly Q, then he will be late for school. So that is T. So T is that he will be late for school. So not Q and then arrow T. John doesn't wake up late and does not miss the bus. The symbol for and kind of looks like an A, except you don't cross it. So it kind of looks like a capital A, but just don't cross the A. So John doesn't wake up late. That's the opposite of P. So we're going to have not P. And, so again, it looks like an A sort of. Does not miss the bus, which is Q. So not P and Q. And this last one isn't even really a full sentence. It just says, therefore, John is not late for school. Therefore is the 3 dots. Looks kind of like bowling ball holes or something. So the 3 dots, John is not late for school. Now T is John is late for school. So we have to negate that. So squiggle T. So the 3 dots is the therefore. So I'm sorry, I kind of almost skipped that section. Down here are our laws of validity. So we're going to figure out which one it is. I think it says A, B, and C for each of those. So that'll go in the box. And then it's what conclusion can you make? So if Caleb studies, that's the first thing, he will pass the test. It says he did not pass the test. So the second thing didn't happen. So if we look up here, that's going to be this one, law of contrapositive. If P, then Q, but Q didn't happen. So law of contrapositive is C. And if he didn't pass the test, what that meant is that he didn't study. So Caleb did not study. So if he studies, then he passes, but he didn't pass. So that means he must not have studied. All right, so this one says, if you fall in the mud, then you're going to get dirty. Jane fell in the mud. So if you look at your law of detachment, it's if P, then Q, and the first thing happened, P happened. So that is V for law of detachment. So if you fall in the mud, then you're going to get dirty. Jane fell in the mud. So what that means is Jane got dirty. I don't usually worry about the laws so much. I just kind of think about what makes sense. Like you read it, it's going to make sense. So this one's, if Joseph gets a job, he's going to make money. If he makes money, he can save for a car. So that's your law of syllogism. If the first thing, then the second thing, and then if the second thing, then the third thing. So if he gets a job, then he can save for a car. So if Joseph gets a job, he can save for a car. And then this last one at the bottom here is about a counterexample. A counterexample is proof that something's not true. So like if somebody said to you, if a number is odd, then it's prime. And then you could be like, well, what about the number 15? 15 is odd, but it's not prime. So it's like you're giving an example of how that wouldn't work out. All right, so these are all of our like alternate interior angles and all things like that when you have your lines being parallel. So you're going to look at these little clusters of numbers here. So we have like corresponding angles and alternate interior and all of that. So which of the following conditions would prove that both the lines are parallel? So A and B, and then also C and D. The trick is you have to get 2 of them from each cluster in order to match them up. So if we look at choice A, 3 is congruent to 7. So that would be these 2 right here. That would prove A and B are parallel. So you get 1 from this little cluster here and 1 from this cluster here. So 3 and 7, that would prove A and B. And then if you get 7 and 15, you have 1 from this little cluster of numbers and 1 from this little cluster of numbers. That's going to prove C and D. So you have 1 of each. So actually it is the first choice. Let me just look at maybe one of the other ones to show you why it's not. This one matches up 1 and 7. And the problem with that is those are both from the same little cluster of numbers, so it doesn't match to anything else. And if you go through the other choices, similar things are going to happen. You have to get them from each of the clusters of numbers to prove that they're both parallel. All right, so here we're told that the lines are parallel. M is parallel to N. It says angle DCH. So if you look at those letters, you have D and then C and then H. That's going to be this angle right in here. That one's 3x minus 10. And then we have EFH. So again, if you like match those up, you have E and then F and then H. That's going to be this angle right here is our 2x minus 25. Now they're either equal to each other or you add them to equal 180. So it's one option or the other. So we're going to think about whether these are equal to each other or whether you would add them to equal 180. So if you take this like angle DCF, if you kind of slide that down, it's going to match up with this one. So this one would match up here. And so if you add these two, you're going to get 180. So we're going to take our 3x minus 10 and then add our 2x minus 25 and have that equal 180. And then you just solve that like solving a regular equation from algebra 1. We're going to put our like terms together. So 3x and 2x will be 5x. And then negative 10 and negative 25 will be negative 35. And then still trying to get x by itself, you would add the 35 over. So 5x equals, what is that, 215? And then divide by 5. So that is going to give us, what is that, 43? Now, sometimes that's it and you're done. Sometimes you have to take that and plug it back in. So just make sure you go back and read the directions. And we are going to have one more step here. It says, find the measure of ACB. So if we look at ACB, A and then C and then B, that's this one. That would be equal to the one right across from it, since those are vertical angles. So you have to take 43 and plug it back in for x in the 3x minus 10. I'm going to just put that in the calculator. So if I go to my calculator, it would be 3, and then we're going to plug in the 43 for x and then minus 10. And so that gives us 119. So your final answer to the whole thing is 119 degrees. But just be careful, because on the SOL, they might make 43 one of the answer choices to try and trick you. So just make sure you go back and read the direction. All right, and then here we know these two lines are parallel, and we're looking for angle X. So it's kind of like a scavenger hunt, sort of. You sort of start with the ones that they gave you and build from there. So I would look at this one first. A straight line is worth 180. So if you do 180 minus 122, it's going to give you this one in here. And so that one would be, what is that going to be, 58? I should just pull up the calculator instead of trying to do it in my head so that you can see it. So yeah, if you do 180 minus 122, that's going to come out to be 58. So we got 58 for that one. And then this is a triangle in here. And the angles for a triangle also add up to 180, which is kind of interesting. A straight line is 180 and a triangle is 180. So if I do 180 minus both of those, it'll give me this one, the last one for the triangle. So again, I'll just pull up the calculator. So we're going to do 180 minus 51 and minus 58. So we get 71 for that one. And then again, we have another straight line here. So if I do 180 minus 71, it's going to give me X, the one that we're looking for. So 109 will be our final answer. So you just start with the ones they give you and kind of look and see if you have straight lines, or like I noticed that this made a triangle. Usually stuff adds up to 180. That's a really common number to use. So you can kind of use that sort of like a scavenger hunt until you get to the one that you're looking for. All right, here we're going to do our formulas for distance and midpoint. But the really cool thing is the calculator will actually do this for you. So we're not going to need to do any work for this. Just watch and I'll show you in the calculator. So if you just type in distance, just the word distance, start a parenthesis, I'm going to put the 2 points that are on the paper. So I'm going to put another parenthesis, -3, 5. So I just type that one in. And then you need to put another comma. And then I'm going to put the other point, which again, I'm just reading it off the paper here, is 4, -2. And it will literally tell you the answer. So if you just type the word distance and then put the 2 point, now you have to get the commas and the parentheses in the right place, but it's just 1 point, comma, the other point, it'll tell you the answer. And then what I can do is go and type in all of the answer choices and see which one matches that. So the first answer choice is 2 square root of 17. So when I type that in, they are not the same. So it is not A. So I'm going to try the next one. It's 7 square root of 2. And do you see how they're the same? Then that's your answer. So if you just type in distance and the 2 points, it will tell you the answer. And then you can test all of the answer choices until you get the right one. So it's cool that the calculator will do that for you. And the calculator will also do a midpoint as well. So given AB, you have these points that are the ends of AB. What is the midpoint? So again, just watch and I'll share the calculator screen. It's the same thing, just instead of distance, you're going to type midpoint. And then again, I'm going to type these 2 coordinates in. So 2, 5 and -4, -2. So again, you have to get the parentheses in the right spot and you have to get the commas in the right spot. But it's just 1 point, comma, the other. Now you might be like, hey, wait a second. It didn't show up. If you click label, it'll label the point for you. So it's -1, 1.5. Now for this one, it is giving you a midpoint, but like the calculator, you can't just type in midpoint and have it do that. Like it gave you the midpoint already. So we're going to have to like actually think a little bit further through this one. So we have A, B, like if you want a visual, here's A and B. And they gave you that A is 2, 2, and they gave the midpoint is 4, -2. B is the one that we're trying to find. What I would do is I would put them into Desmos and look at them and just kind of count the little boxes to get to the last one. I think that's the easiest way to do it, is to have a visual and just look at it on a grid. So I'm going to plot 2, 2. And again, you can make it label that for you. So there's 2, 2. And then we had 4, -2. I'm going to label that one as well. So this is A, and actually you can make it call that A if you really want to. And this is M. I need to find B. So B is going to be like down here somewhere. And I would just, remember slope from Algebra 1? I would just count out the slope. We're going down 1, 2, 3, 4 boxes, and then right 2. So I'm just going to count down 4 more, and then over 2. So where my cursor is right here is our answer. And so we just need to figure out what that coordinate point is for right here. And it lines up with 6, -6. And what you can do too is I'll type it in 6, -6. Oops. And you can kind of see how they line up. Or, I mean, you could test numbers if you were like, hey, 6, -5, and then you could be like, oh, well, that doesn't really look like it lines up. Like you could test numbers until you get it to work. But I think looking at it visually is the easiest way to see that. So I would just type all the points in until you figure it out. So 6, -6. These ones we're given a grid that we can kind of write on here. And it's nice on the SOL if they give you the grid. Usually they have like a highlighter and you can highlight things on it. We're going to do parallel and perpendicular. So we are given line T. We want all the points. So we're going to circle more than one thing here. It's multiple choice, but you're going to circle more than one answer that goes through point P that's parallel to this line. So parallel means they're going to run along next to each other and never touch. And so it means the same slope. So I would bold like a few more of these points here to try and see what the slope is. And we're going up 1, right 2. So up 1 over 2 is our slope. So from point P, I'm just going to do the same thing. Just go up 1 over 2. And actually, I'm going to just keep that pattern going further because I didn't look at the choices yet, and I don't know how far it's going to need to go. So I just kind of bolded all of them. And we're just going to select anything from this list that is one of these points that I highlighted. So if we look at 5, 2, wait, 1, 2, 3, 4, 5, 1, 2. So 5, 2 is this one right here. So that is one that we want. And then 4, 3. So 1, 2, 3, 4, 1, 2, 3. So 4, 3 is not one of the ones that's bolded. So we do not want that one. 7, 3, 5, 6, 7, 1, 2, 3. 7, 3 is this one. So we do want that one. 1, 0 is right here. And we do want that one. 0, -5 would be all the way down here. So that is not one that we want. And then -7, -4 is this one. And so we do want that one. So this one's -7, -4. So you're doing all of the choices that work for that. And that could show up like a drag and drop question on the SOL, like drag and drop all the answers that are possibilities. So they sometimes do that. This one's the exact same thing, except it says perpendicular. So we said this slope was 1 over 2. So up 1 over 2. Gosh, I don't have any space to write this. I'm going to write it over here. So that slope was 1/2. For perpendicular, you do two things. You change the sign. So if it's positive, you make it negative. If it's negative, you make it positive. And then you flip it over. So instead of 1 over 2, we would want -2 over 1 for this. So through point P, I'm going to go down 2 and right 1. And again, I'm just going to keep that pattern going for as far as I can on the grid. Because again, I didn't look at the choices yet and I don't know like which ones are going to be there. But if you were to connect them, you can see that it would be perpendicular, which means they meet at a right angle. Like if you connected this, you would be like, oh, okay, it looks like they're going to meet at 90 degrees. And so again, we're just going to read through all these choices and pick the ones that line up with the points that I bolded. So 1, 2 would be right here. That is not one of the ones that I bolded. So we don't want that. 2, 3. So 4, 3, again, that's this point, which is not one of the ones I highlighted. So we do not want that one. 4, -1 is going to be this one. So we do want that. Here's 4, -1. So we want that one. -1, 3 would be all the way over here. So that is not even close to the line that we have. So we do not want that. 5, -3 is this one. So we do want 5, -3. And then 6, -5 is this one. So we do want that as well. So C, E, and F. All right, and then this is all of our symmetry. So line symmetry, point symmetry, and then transforming everything. So here, choose all the correct lines of symmetry. Just gonna real quick review a vertical and horizontal line. And you probably remember from Algebra 1, or it might have been brought up this year, is Hoy-Vux. A horizontal line is gonna be y equals, and a vertical line is going to be x equals. So when we look at x equals 5, and you can always type x equals 5 into Desmos as well and look at it, that's going to be a vertical line at 5. So here's 5. If I draw a vertical line at 5, that's not even touching the rectangle. So that's not going to be a line of symmetry. It doesn't even go through the shape. If we draw in x equals -2, so again, x equals means it's going to be vertical. Here's -2. So if I draw in a vertical line at -2, do you see how that's cutting it exactly in half? Like if you folded it on that line, it's cut exactly in half. So we do want that one. But there might be another answer. It said circle all of the correct choices. So we're going to keep looking for another answer. So these are both y equals, that's horizontal. So if I draw in y equals 5, that's going to be a horizontal line here at 5. And so if you draw that in, you can see it goes straight down the middle. So like if you folded it on that line, that's going to be a line of symmetry. It would be the same. And if you draw in y equals -2, that's going to be all the way down here where -2 is. So that doesn't even touch the shape. So that can't be one of the answered. Are you doing okay? Okay. And again, if you forget which one is which, you can always go into Desmos. Here, I'll show you. And if you type in, like if you can't remember which one's horizontal, which one's vertical, like if you type in x equals 5, it'll show up as a vertical line at 5. And if you type y equals 5, it'll show as a horizontal line. So if you forget which one's which, you can always type it in and it'll show it to you. You can use the calculator for so much stuff. All right, so given these pictures here, circle each one that has point symmetry. So point symmetry means you rotate it 180 degrees and it'll be the exact same. So that's like you take it and spin it around so it's facing the other way. Like you need to think of it, trying to think of a like real life example, like something that you turn, like turning a doorknob, I guess, like turning it halfway around and it would be the exact same. So if you think of the smiley face, if you take it and like twist it, like if you turn it around, it will not be the exact same. It would be a frowny face instead of a smiley face. So that one does not have point symmetry because if you flip it around, it's not going to be the same. This one, if you take it and turn it 180 degrees, it will be the same. So this one does have point symmetry. So we're going to circle that one. So it's just if you spin it halfway around. So this one, if you spin it halfway around, that's not going to work because the little cut out piece would be on the other side instead. So that's not going to be the same. So we don't want that one. And then this one, if you spin it 180 degrees, it will land right where it was before. It's kind of like flipping over an hourglass. So that one would have point symmetry. We're just going to flip it the other way. All right, so we circled the ones with point symmetry. And then underneath each figure, identify the number of lines of symmetry that exist. So like what we were doing with this one, you want to figure out a way that you can cut it exactly in half. So like if you folded it on that line, it would be the same. So the smiley face is only going to have one. If you cut it right down the center, it would have one line of symmetry. And then this one's actually going to have two. You can cut it down this way and it'll be the same both ways. But if you cut it going this way as well and fold it along that line, it would be the same going that way too. So that one has two lines of symmetry. And then the little Pac-Man looking thing, that one's only going to have one. If you cut it across here, it would be the same on both sides. So one for that one. And then this one's also going to have two, just like this one did. So if you cut it vertically right there, or if you cut it horizontally along those lines, it's going to be the same both ways. So that one would have two. All right, and then these last ones are kind of tricky. These are transformations. So you're taking this shape, like taking the points and spinning them and reflecting them and shifting them around. So these ones are actually kind of hard. We're like sort of ending with the hardest thing here. So ABC was reflected over the line y equals x. I'm going to just go ahead and dot in y equals x. It goes through the origin and goes up 1 over 1. So it's going through 0, 0. And it has a slope of 1. And again, if you ever forget what that looks like, you can type y equals x into Desmos, and it'll show up for you. So if you like type y equals x, it'll show you it's that like diagonal line. So we want to reflect over that line. And actually, we're just taking point A. So really, you don't need any of the rest of this. We're just looking at point A. So we're going to reflect over that line. and then do more stuff to it after that. But first, let's do the reflection. So point A is at -5,2. So I'm just going to kind of write that in, -5, 2. If I reflect that over this line, and I usually just sort of eyeball it and then figure out what the exact point would be, it's going to be down here somewhere. So like if I take A and reflect it, it's going to be down here. And since this is -5, 2, the point down here would be 2, -5. So that's where it got moved to when we reflected, is 2, -5. But again, I usually just kind of like go, oh, it's going to be about there, like in the vicinity, and then look at the numbers and go, okay, well, if this is -5, 2, this is going to have to be 2, -5. But then there's one more transformation that's going to happen to it. We're going to add 2 to the x. So 2 plus 2 would give us 4. And then we're going to subtract 3 from the y. So -5. And then if you subtract 3 more, we'll give you -8. So this is where you end up at the end. And again, that's really hard. If you were like, hey, that was a hard question, you're right, it is. Like the transformations are just hard. Especially the rotating, you always rotate around the origin. So the origin is kind of the fixed point. So we're going to rotate 90 degrees clockwise. So again, I usually just kind of eyeball it. If I take point A and go 90 degrees clockwise, it's going to end up like over here somewhere. So point A is going to end up in the first quadrant. And so I'm like, well, it's going to be like sort of close to over here. And then I'll look at the numbers and go, okay, if I know it's going to be somewhere over here, if this is -5, 2, it's going to have to be 2, 5. So again, I'm just imagining like rotating this 90 degrees. I know it's going to have to be up here somewhere. So 2, 5 is the point that kind of like makes sense for that. So I took it and rotated it 90 degrees around the origin. Like, and if you kept going, it would rotate the whole way around and eventually get back where you started. You're going around this as a center point. All right, and then there's another transformation. We're going to reflect it over the line y equals -2. I know I've already drawn all over this picture, but I did color code it. You can't really see too well on the projector, but I'm going to dot in y equals -2. So maybe just watch me point to it. I'm going to take this point, this 2, 5, and I want to flip it over this line. So it's going to end up all the way down here somewhere. Like I actually think it's going to go off the grid. This point is, I would just count how many units. 1, 2, 3, 4, 5, 6, 7. So it's 7 units away from the line we're trying to flip it over. So when it comes down here, it's going to be 7 units away in the other direction. So 1, 2, 3, 4, 5, 6, 7. So it goes 1 point off the grid. What does that go to? -8. So it would be at -9. So it would be at 2, -9. Again, I think those two are honestly the hardest questions on this whole packet. I know easy and difficult is always an opinion thing, but I think those are really hard.